Alrighty, let's see what we got here. It is Walking Robot Simulation Part 2. A width x height grid on an xy plane with the bottom left cell at 0, 0 and the top right cell at width -1, height -1 is on the x. The grid is aligned with the 4 cardinal directions north, east, south, west. Okay. A robot is initially at cell 0, 0 facing east. Okay. The robot can be instructed to move for a specific number of steps. For each step, it does the following. It attempts to move forward one cell in the direction it is facing. Okay. If the cells the robot is moving to is out of bounds, the robot instead turns 90 degrees counterclockwise and retries the step. Okay, always counterclockwise, so it turns right. No, it turns left, After the robot finishes moving the number of steps required, it stops and awaits the next instruction. Implement the robot class, robot int height, int width, int height initializes width x height grid with the robot at 0, 0 facing east. Function step takes an int number, instructs the robot to move forward number of steps. Get position returns an array for the position xy, and string get direction returns the current direction of the robot. Okay, this seems pretty straightforward. So robot initialize step 2, robot initialize was 6, 3. Okay, the grid is 6, 3, 6 rows, or 6 width, 3 height. Okay. It's 2 steps forward, so it's here, 2 steps, another 2 steps forward, so it's here. Oh, it's in yellow spots, okay. And then get position, get direction. Get direction returns the string, okay. And then step takes another 2 steps, so it goes here, takes another step, so it goes here, takes another 4 step. Get position, get direction, okay. Seems straightforward enough. There's no obstacles. I'm wondering if this needs to be 10 to the 5th numbers. At most 10 to the 4th calls. Num is 10 to the 5th. What is num? Is that the number of steps? Oh boy. Okay, yeah. So it does. That's a lot of steps, right? So there needs to be some sort of shortcut to reducing that amount so that doesn't. So I can't just like I can't simulate each step. I need to probably figure out where the end position and direction is based on the initial position, direction, and number of steps and size of the grid. Okay, so let's do the simple stuff first. So let's go ahead and store stuff. I'll use so I just use W for width and H for height of the grid, or rows and columns. Rows and columns might make sense, although it might not, because X and Y often get very, very confused with rows and columns. I'll just store it as currently W for width. And obviously I'll need to store the current position. Okay, and the current direction. I guess I'll store direction using dx dy for the movement that the direction would involve. So self.dx comma self.dy equals change in x is going to be +1, and the change in y is 0 when it's facing east. And then let me go ahead and just pull up yesterday's deal. Yesterday had something very similar with the transitions between movements. What the heck's going on? Okay, so the rotation here is, it's always going to be rotating left, so it's going to go case -2 dx dy is that. Okay. So there's actually no rotation thing, right? Okay. So rotation only occurs. Okay, so I just need to make note of that. Get position should be pretty straightforward. This should just return the array that is self.x, self.y. And then get direction. I need to translate the current movement into an actual string, right? So I'll say should I declare? I'll say direction is going to be a mapping of, let's say, 1x 0y maps to east, -1 0 maps to west, 0, 1 maps to north, and the tuple that is 0, -1 maps to south. And then just get direction, so it's going to return self.direction dictionary, passing the tuple that is self.dx, self.dy. Okay. So now we'll just have to deal with the main part of this problem, which is identifying how to move and correctly position. So like if, for instance, if this is at 0, 0 and it said step, 10,000, how would it quickly determine what to do? Loop de loop de loop. Always turns left. Okay, so it always turns left. So once it enters kind of the edge, although if it was something weird, actually it's always starting at the origin or starting at 0, 0. It's always doing this loop, right? It's never actually in the middle. It cannot possibly enter the middle section because it just goes to the edge, loops. Yeah, okay. So it's just a continuous loop. Okay, and then its position and facing is strictly based on the number of steps it's done, I think. right? There's no rotation thing. It can move here. So it's never like if it's in this position on the first loop at 5x0y, it's always still facing the wall, facing this side here. It hasn't rotated. So it's even at this position, it's always going to be facing east. At this position, it's always facing north. At this position, it's always facing north, right? So let's see, yeah. Only when it, yeah. Okay, so it's very static in terms of a position mapping to a particular direction. Okay, so based on logic of movement and turning, robot will always move in the same circular counterclockwise loop on perimeter of the grid. Additionally, for any given position on that loop, the facing will always be the same. So it's so very static. The step count will determine everything. So just based on number of steps. Okay, so let's see. If the step count is between 0 and the number of columns, which is the width, it'll be facing east. If it's between that and width plus height minus 1, it'll be facing north. Okay, so I just need to do like a modulo thing here. So when would it at the very first position, it should normally be facing north, I want to say, or facing south. So it's actually unusual that this position is facing east based on just being step 0. But every other time when it's in this position is facing south, and that math. Okay, yeah. So I think here I'm going to do something like if step is equal, sorry, I'm in the wrong area, huh? I wonder. So what I'm thinking of here is maybe step just needs to keep track of the step count. And then maybe step needs to just keep track of the step count, and I actually just derive the actual thing based on that. Self dot count plus equals num. Okay, so I don't worry about any sort of rotation actually. And then, so position is just going to be something like I think I start by doing self dot count what do I do here? Let me do a basic one. Let's say there were step 0, 1, 2, 3, 4. So like a 3-row, 4-column, 5, 6, 7. God, yeah, I'm horrible. Three rows, 4 columns. So the number, so if the number of rows and columns is 3 and 4, it should be like rows times 2 plus columns times 2 minus 2, since there's like 2, 3 plus 4 plus 3 minus 4. 4, 4, 1, 1, excluding the 4 corners. Yeah, so it's rows plus columns. Rows times 2 plus columns times 2 minus 4. Perimeter. Spelled it wrong. Perimeter equals rows times 2 plus columns times 2 plus minus 4. Corner subtracted. Okay, so I think it should be the position. So I'll do P for perimeter, or perimeter per. Is there another word for that? Length. Size. No, I'll use perimeter, whatever. So this should be 2 times width plus 2 times height minus 4. Okay, so position should just be, so actually I don't think I want to keep track of its current position. I don't want to model it that way because it requires more calculation than needed, to be honest, right? I'll just calculate on the fly whenever it's asked. Because strictly speaking, it's all based on all function of the single value of the count of number of steps. So I think I'll do something like current number of steps is, or let's say the remainder, which is going to be self dot the count of number of steps modulo self dot the perimeter. So that will take it down to something between 0 and, so here the perimeter is 10 values, so 0 and 9. Right, okay, so then I just do something like this if statement, I think. If the remainder is less than the number of number of the width, right? The width is less than self.width. Okay, maybe I did need that. Self.w. So it's like between 0 and 3 where the width is 4. That means it's on the bottom. So it should return 0, comma 0, comma the remainder, I think. And then else if the remainder is less than self.w plus, so this would be 4 plus 3 minus 1. self. So 4 plus 3 is 7, minus 1 is 6. So less than 6, so 0 through 5 at that point. Return, it should be on the left, on the right edge, right perimeter, right side of the perimeter. So it should be self.w minus 1 as the x value, and then self.h. So 5 becomes 2, 4 becomes 1, 3 becomes 0. So I think this should be, the remainder is 5. So the remainder minus, remainder is 5. Remainder is 3 becomes 0. But that doesn't matter. Remainder 4 becomes 1. 4 becomes 1. So the height is, yeah, I think it's like self plus 1, something like that. So if it's 4, if the remainder is 4 and the height is 3, 4 minus 3. I think I should be subtracting the height, right? Should I be subtracting the height or should I be subtracting the width? I should be subtracting the width. So it should be remainder minus self minus the width plus 1. Alright, I think that's right. So if the remainder is 5, the width is 4, because the amount of stuff after it passes the width's length is how much it is going up by, which is the y coordinate. Okay. Else if the remainder is less than, so we're talking about this thing, or this value here. So like it's width at the bottom, width plus height minus 1, 2 width plus height minus 2, 2 times self.width plus self.height minus 2. Wait, do I need to do this minus 1? 4 plus 3 minus 1. That's not readable. I think this is right. So this would return, so at this point it should be at the top side of the perimeter. So the y coordinate should be fixed, which is going to be self.height minus 1. And then the value should be remainder minus, like, it should be minus like self.w plus self.height minus 1s or something like that. But it's backwards. Fuck. It's backwards. Oh my god. 6, 7, 8. So if it's backwards, then I think the remainder needs to be the thing that's being subtracted. The remainder is the thing that's being subtracted. Yeah. This is I'm gonna be surprised if this works in the first try. I'll be very, very surprised. Okay, so just need to work on my algebra. So the remainder here is 8. 8 should correspond to 0. So 8 goes to 0. 7 goes to 1. 6 goes to 2. Where this is the remainder value. Right. So 8 is so width, so 2 times width plus height is going to be 2 times 4 is 8 plus height, which is 3, is 11 minus 2 minus 3 somehow. So it should be 2 times self dot w plus self dot h minus 3 minus remainder. Guess. If there's a better way of making sure this logic holds. I don't know. Okay, let's just try a different problem. So let's do, I'll just do a simpler one. 0, 1, 2, 3, 4, 5, and then going backwards. 9, 8, 7, 6, 5. No. Alright, how about that? 5 by 2. So if the remainder is 8 here, it should map to 1 on the x. 7 maps to 2 on the x. So here the width is 2 width plus height minus 3 is going to be 2 times 5, which is 10 plus 2 minus 3, which ends up being 9. 9, and then subtracting the remainder is 1. Okay, so I think that's right. Okay, else if the remainder let me double check if this part is right. So if this is, the width is 4, the height is 3, this is 8 plus 3 is 11 minus 2 is 9. So 8 is less than 9. Okay, yeah. The remainder is, well, there's no. So this is the last part. So this is on right side. This is on top side. This is going to be on left side. So therefore the x coordinate should just be 0. Why is this wrong then? Oh yeah, I switched this up. Fuck. Yeah, it should be remainder comma y 0 there. Okay. Here the x coordinate should be 0 and the y coordinate should be variable. Right, so this thing, okay, yeah. The y coordinate should be variable. And this is also backwards compared to the left side. So I need to subtract remainder for this one. And my guess this is going to be something like, I could probably use self.perimeter in this one. So here if the perimeter is 10, then, and it's 9, then it's 10 minus 9 is 1. Or the perimeter here is 10, 10 minus 9 is 1, 10 minus 8 is 2. Okay, yeah. Yeah, so it's self.perimeter minus remainder. Okay. Okay, so that's maybe the easy part. Actually, this part should be pretty easy too. So the special case is start if self.count is equal to 0, return east. Otherwise, I just need to do this logic here. If it's remainder, if it's on the bottom side, return east. No, fuck. Except. No. This is wrong. The remainder has to be slightly different. Okay, self.count remainder is equals to self.count mod self.per. Okay, yeah. And then I do something like maybe it's just, this is incorrect actually. So here, if the remainder is 0, then this thing, the logic here is I'm going to assume that this thing's going and self.count is greater than 1. So I'm back at position 0 and greater than 1, so this should return south. Okay, yeah, I think that's right. And then everything else aligns with the previous logic. So this is going to return east if it's in the first bottom row. Normally if it's in this position it should be going south as long as it's past the first loop. So, but this is the special case there. Okay, and then else if, actually I'm going to go ahead and just copy this, because we're still doing the same sides, it's just returning strings for the direction instead of arrays for the position. This is going north at this point. Top side it's going west. And left side it goes south. Alright, I don't think I need to worry about dx dy or having this dictionary or storing the position. The perimeter is a constant. Okay, see how this goes. Unterminated string. Whoopsie. Oh. How ominous. Alright, cool beans. Alright, so what to say about this? Summary. Did some kind of algebraic math based based on the above logic, and basically created functions or logic that maps the step count to the position of the robot. Since the robot will go in loops, whenever these steps are go in loops, when the step count does one perimeter length, which is 2 times width plus 2 times height minus 4, it will be in the same position as before. Thus, use the remainder of step count modulo perimeter to help determine the position. Similarly, use logic to map the directions. So yeah, like if the perimeter of a 3 height 4 width thing, the remainder of like that, the perimeter there is 10. The step count mod 10 is going to give you a value that maps to one of these 10 positions, and then use some logic to determine, based on that remainder, what the where it is on the bottom, right, top, or left sides, and just have to be really careful about that logic. Hopefully it works out. Alright, time complexity, this is going to be O of, I don't even know what this means. Time complexity of what? I'm guessing this is time complexity of the actual calls to get position and get direction. This is all O1 for all functions, since every call does a constant kind of operation work, no loops. There is no simulation of step movement of the robot, nor code does not track position forward facing. It calculates that on the call of those methods based purely on the step count. Space complexity is in the O of 1, since no extra space is needed.